Alrighty folks, in this video we're going to go over how do we use the chain rule to take a derivative. Okay, so first of all, when do we employ the chain rule? When do we use the chain rule? We're going to use the chain rule anytime we're dealing with a composed function. What I mean by that is, here's the rule. Let h of x be f of g of x. What that means is that we have a function within a function. And so then it turns out that the derivative of that composed function, f of g of x, is h prime of x equals, it's f prime of g of x times g prime of x. So I get it. It's a lot of variables there. But what you're seeing here is that basically to take a derivative via a chain rule, what you're going to do is you're going to take the derivative of the outside part of your function, and it's going to be multiplied by the derivative of the inside. Okay, so think of the chain rule as an outside derivative being multiplied by an inside derivative. All right, let's get into a couple of questions here. Okay, for example, we have f of x equals the quantity x cubed minus 5 is raised to the 4th power. So without the chain rule, the only way that we could really solve this using the rules that we know up to now is we would have to multiply that out 4 times and then use our sum and difference rule to find the derivative. But the chain rule is going to be a lot quicker for us. Okay, so really quickly, I want to identify what I mean by outside versus inside. Okay, so as we look at this function, the outside portion of the function, what I'm talking about is that we are taking something, okay, it doesn't matter what the something is, we're raising it to the 4th power. Okay, so how we take the derivative of something raised to the 4th power? What do? We bring the power out front, the 4, and it multiplies that thing raised to the 1 less power, in this case the 3rd power. Okay, so specifically, what's the inside part of our function? For this particular example, the inside part is the x cubed minus 5. Okay, so then once again, we should know how to take that derivative from a previous lecture. So we're going to put those two concepts together. Okay, so our derivative is going to be the of the x cubed minus 5 to the 4th power. It's going to be the derivative of the outside part of the function times the derivative of the inside. So what does that look like? Here we go. F prime of x will equal, we're taking the derivative. Okay, we're going to start with the outside derivative. And what that indicates is we're going to take that power of 4, okay, and we are going to leave the inside alone. Whenever you're working with an outside derivative, be sure to leave the inside alone. Okay, so we have 4 times x cubed minus 5 to the 3rd power. Okay, this is the outside derivative. And then now it gets multiplied by the derivative of the inside. And what do we say the inside is? The inside is just the x cubed minus 5. So what's the derivative of x cubed minus 5? Well, the derivative of x cubed is a 3x squared, and the derivative of a negative 5 is 0 because it's a constant. And there we go, folks. That is the chain rule. That is our derivative. All right. So one more time. This part of the chain rule is the outside derivative. This part of the chain rule is the inside derivative. Okay. Now, if we wanted to, we could clean up the solution a little bit if we wanted to. Now, if we wanted to, what we could do is we could take this 4. So it's 4 times x cubed minus 5 to the 3rd times the 3x squared. Well, because of orders of operations, I cannot distribute that 4 to the x cubed minus 5 because I would have to, I have that exponent of 3 there, so I'd have to expand, multiply it by itself 3 times first. But the 4 can distribute to the 3x squared. And 4 times 3x squared is a 12x squared. So your answer could also be written in this equivalent form. Okay? So I just want to show you here how the equivalent forms in which your answer could be written. Your homework should be good either way. But the key is it's the outside derivative times the derivative of the inside. Let's look at another one here. Alright, so for example, we have f of x is 3 over the square root of x squared plus 2x minus 1. So before applying the derivative here, the chain rule here, we have to do some rewriting. We have to get it into the form of the chain rule. So what I'm going to do is I'm going to do this in 2 parts here, in 2 steps. Feel free to do it all in 1 step if you understand all the parts here. But I'm just going to rewrite that square root of x squared plus 2x minus 1 as x squared plus 2x minus 1 to the 1/2 power. Okay, if you need a refresher on how to rewrite radicals as fractional powers, go back to the power rule video. I did a few of those in that one. But it's to the 1/2 power. And then the next step I'm going to do is I want to rewrite this function by bringing my denominator up to the numerator. And we know from previous, examples that we know that means we take the opposite of the power. So rewriting this function, it becomes 3 times x squared plus 2x minus 1 to the negative 1/2 power. Okay? So that is our rewriting. That's not the derivative. I repeat, that is not the derivative. But now we're in position to take the derivative. So here we go. What's the derivative? We start with the outside part. And what I mean by that is that 3 is going to be multiplied by a negative 1/2. Okay? We're going to leave the inside alone. X squared plus 2x minus 1. But now I need to subtract 1 from the power. I need to subtract 1 from the power. So what does that give us? Well, a negative 1/2. Maybe I'll do it up here in a different color. A negative 1/2 minus 1, which is the same thing as a negative 1/2 minus 2/2, is a negative 3/2. So the new power becomes a negative 3/2. Alright? So keep in mind, all of this that we've done is just the outside derivative. Okay? Do not forget about the inside derivative, which will be the derivative of x squared plus 2x minus 1. And I need to put this in parentheses because I have more than one term. Okay? So it's going to be a 2x plus 2. Where does this come from? This came from the derivative of the inside, just the inside. When you work with the derivative of the inside, you ignore the power that's on the outside of the parentheses. Okay? And as I said, this is the inside derivative. Okay. So you may have a question. Are the parentheses necessary? Yes. Because if I write it like this, only the 2x is being multiplied by everything else, whereas I want the entire 2x plus 2. So yes, parentheses are absolutely necessary. Okay, let's clean this up a little bit. So 3 times a negative 1/2, that's going to give us a negative 3/2. Okay, x squared plus 2x minus 1 to the negative 3/2 times 2x plus 2. All right. And then the next thing I want to do is I want to now just kind of put this all together as a single fraction. So what I know is that I have a negative 3 in the numerator. Okay, that negative 3/2 power there. That negative 3/2 power there. I want to move this entire term to the denominator. What if I want to write it with positive powers? So that means that needs to go in the denominator. So we have x squared plus 2x minus 1 to the positive 3/2 power. And guess what? That 2 from that negative 3/2, that's already in the denominator, so let's go ahead and put it down there. So there's our negative 3/2. And then the 2x plus 2 stays in the numerator because it had an understood positive 1 power, which indicates it's in the numerator. Okay. So if you're working with your homework, it should accept either one of these answers, but if it's a situation where it's a multiple choice, I do want you to be able to recognize that these are equivalent answers. Okay, so hopefully this is clearing it up. How do we take a chain rule derivative? The derivative of the outside times the derivative of the inside. Okay, one last quick little problem. Okay, so h of x is f of g of x. Okay, so if g of 2 equals negative 3, g prime of 2 equals 4, f prime of 2 equals a negative 1, and f prime of negative 3 equals 2, they want us to calculate h prime of 2. Excuse me. All right, so with this one, this is more of an abstract type of problem, meaning there's not really a function for us to work with here. Okay, so this is what we're going to do. So we know h of x is f of g of x. That we know. Okay, and so let's go ahead and take kind of this derivative. this abstract derivative, so to speak. So h prime of x, okay, is the derivative of the outside, so it's f prime. Notice f is the outside function. F prime, remember I'm telling you, leave the inside alone. But then it gets multiplied by the derivative of just the inside. Okay, that's just our definition of a chain rule. Now, let's talk about h prime of 2. And all this means is that everywhere I see an x, I'm going to replace it with the value of 2. So that means we need to figure out f prime of g of 2. And we need to multiply that by g prime of 2. All right. The good news is we know all these values. They give us all these values already. Okay? So what is g of 2? G of 2 is a negative 3. So this becomes f prime of a negative 3. All I did was replace g of 2 with this value. Okay? Let's talk about g prime of 2. They tell us that g prime of 2 is 4. So I'm going to replace g prime of 2 with 4. Okay? So our answer is going to be f prime of a negative 3 times 4. All right? So what is f prime of negative 3? Well, f prime of negative 3, let's get a different color here. What's f prime of negative 3? F prime of negative 3 is a positive 2. They told us this. So f prime of negative 3 is 2, so that indicates that we're looking at our final answer is going to be 2 times 4, which is simply 8. Okay? So why was our answer numerical? If you remember the tangent line homework or video lecture, remember when we evaluated at a particular x value, what we're doing is we're finding the numerical value of that slope there. So that's what they're asking for. And notice with this question here, notice they gave us some extra information that we did not have to use. Okay, so be careful. There was no need for us to use f prime of 2 because that didn't come about using the chain rule formula. Okay, folks, I hope that helps you out with your homework. I'll see you guys in the next video.